Today, I gonna walk through our final project, which is delving into the Q&A network. We use text mining and graph analysis. The motivation of our project is that Q&A platform is increasingly important for students, engineers, and teachers, scientists sharing their knowledge and get their questions answered. So, as users, we are interested in what are the topics that is heatedly discussed and how easily they can get their problem solved using such platform. Or as developers, people are interested in what users had questions regarding on a certain language or a certain product. So our project addresses such problems by extracting the topics out of the large amount of posts and the topics distribution of each document and predicting the good quality answers by building a predictive model. Also, we visualize the network of questions and get a idea of the trends and relationships among those topics. Our project structure can be divided into two parts. The first part, we gotta conduct topic modeling to extract topic features, and also we gotta combine topic feature with non-text features to conduct predictive modeling, which is used to predict good quality answers. And also we're gonna build our data in the Neo4j database and conduct visualizations and graph queries for that can be generated to the results of a simple recommender engine. The tools we use is Python, Spark, Neo4j, and D3. And the datasets we use the datasets downloaded from Stack Exchange Data Explorer. We choose the data science category as our to conduct our analysis. The datasets simply contain the following information. It contains the post, which can be separated as ask and answers, and it also contains users' information such as reputation, age, and its location, and also some text related to the questions. And the relationship of this database is as follows. Users can answer questions or can ask a question, and answer is related to question, and asked question can have several texts. The algorithm we use for text mining is we're gonna discuss LDA first to extract some text features. So basically the idea of LDA, which is a very basic and very widely used topic modeling method, it assumes that each document contains several topics and each topic has different distribution of words. So LDA can influence the distribution of words on each topic given by the number of topics specified by the user. And also it can also generate the topic distribution of each document. The tools we use is we run LDA on Spark, and we get the result of 10 topics of all the posts we have. And also we're gonna use Spark LDA Sparkline API to get the topic distribution on each document. The result of the 10 topics can be displayed as the word cloud documents and the following. Each cluster is a topic. So we can see that we have some topics related to language such as Python, R, and also some topics related to machine learning and algorithms, and also some topics related to the data processing. The next step, we're gonna predict whether an answer is good answer or not. This is meaningful because predicting good quality answer is useful for ranking the answers, and also it is useful for understanding the successful features that a good quality answer have. We divide the answers into accepted answer as well as not accepted answer. The accepted answer can be determined as good answers, and we process the data by deleting the accepted answer that are given and accepted by the same users to avoid biases. And also we delete those answers that have been edited after being accepted. After processing the data, we conduct some feature extraction. We extract the five different features can such as presentation quality, attitude, which we generate by using sentiment analysis. Time features can be conducted by the waiting time between the questions posed and an answer is given, and a user who answered the question's reputation. And also we combine the topic features from the previous steps. The outcome of our classification method, we run 5 different models. The first model, we include all the 5 different categories of factors, and then we delete one kind of factors and run the model on the 4 remaining factors. And the results shows that reputation, quality, time, features, and attitude features is very important, but deleting topic features may increase the accuracy of the model. So, which means that topic feature is not that important. And also the second not that important feature is the attitude, which is the sentiment of the answers. So from the result, we can see that some basic features that determine whether an answer is good or not is like whether whether the user answers quickly, whether user has whether the answer is long or not, whether the user has reputation or not. And the next part of our project, we deploy our database on Neo4j. So the database can be shown as follows. The red is answers, and the yellow is users, and the gray one is questions. And the questions has different tags. Having this database, we can conduct some simple analysis and extract data out of the database for further use. So the first example I show is that we extract data from Neo4j to draw a network graph of tags using force-directed graph. And here is the example that I use Py2Neo, which is Python API of Neo4j to get the data out of the database. And then I show the data using a force-directed graph. So um, from the graph we can see some tags are the very popular tags are in the middle of the graph, and some not very popular tags are out at the outside of the so at the cluster. And further we gonna further we in further we from the graph we can see that some um, from the graph we can see that some tags some links from the graph we can see that some links is very in overlaps in the middle of the cluster. So we can only get an idea of that this kind of tags is very important, but we don't know how they connected. So the next step we use Neo4j to generate another input format for the binding edge graph. So as we can see that Neo4j is related to CSV, graphics, non-SQL, etc. tags, and some recommendation tags is related to a far more number of different tags. So from this graph, we can see what tags are important and what tags is heavily related with other tags, and what tags is not that important, such as this. Also, the next steps we can also use our database to conduct a simple recommender. Here is an example that I find the questions that does not have answers yet, but we can recommend those users who has answered similar questions with the same tags of the questions we have to recommend those users to answer the questions.